Alright, Math 2, we're going to look at some old theorems, some theorems that you should remember from middle school, and we're just going to kind of really fly through them real quick, okay? And that's what we're going to start with. Alright, first off, we've got the triangle angle sum theorem, and this is that theorem that you know right here, that the three angles in a triangle will always add up to give you 180. So there's your triangle angle sum theorem. Alright, now if you want to get it the long way here in this middle example, and you want to write it out as a proof, I would need to write down that angle A plus B plus C has to equal 180, and then I could substitute those values in. Alright, and then I could continue to go in through and solve. That would be the formal way, and then of course you got your like terms and you can subtract and all that. I'm not going to do that. I'm just going to go through the regular way and just say add those two up, subtract it from 180. I think most of you would do it that way. Over here, I've got triangle angle sum. I'm looking at those, and this time I'm going to add up each of those. That's the triangle angle sum theorem. And again, I'm not going to solve through all of that. But if you solve this equation, you'll find out x is 12. And since I didn't really ask a question on this one, sometimes we want to know the actual angle. Of course, I could plug 12 back into all of those and find out what each of those are equal to. And it turns out that they'll be equal here, 45, 95, and 40. Okay, the next one is going to be the triangle angle exterior angle theorem. Okay, and what we're going to do on that one is I actually have a little bit of a proof here. First, I mentioned that A plus B plus C has to equal 180. That's our triangle angle sum theorem from above. I also know right here that C and D together make a straight line. So that's our supplementary theorem that we wrote down and practiced with yesterday. Well, if A plus B plus C equals 180 and C plus D equals 180, then obviously 180s are equal to each other, so that means that those two expressions are equal to each other. And that's by substitution. Now one more step, since I have a C on both sides, I can subtract that C from both sides, and you find out that A plus B has to equal D. Now, you don't need to see it there. It's written down right here as well. And what that tells us is that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So D is going to be equal to A plus B, and that's what this says. Here's what it would look like over here. Okay, the exterior angle, 3x minus 10, is going to be equal to the sum of the two opposite interior angles. Okay, now I'm not going to do the work. You can do the work and find out that x equals 25. Alright, another theorem to look at. Another theorem is going to be our Polygon exterior angle theorem. Some of you recognize this situation maybe from a science fiction movie. If you take that and pretend this was a doorway, a lot of times this is a doorway in a spaceship, and when they close the door, they move all those in, don't they? And it closes and it makes a complete circle. Well, we know about circles. Circles are equal to 360, right? So that tells us that the exterior angle theorem, the exterior angles, are equal to 360. Okay? Now, easy enough to apply. By the way, that works on any polygon in the world. Triangles, quadrilaterals, pentagons, hexagons, octagons, anything. So over here, if I write this all out, if I write all that out, it's going to be the 70 plus the 60 and the 65 and the 40. It's all got to equal 360. And I find out, of course, that the y has to be 125. Another example down here. I want the size of an exterior angle of a regular decagon. Well, we need to remind ourselves what regular means. Regular means that all the angles and the sides are congruent. Okay? And of course, a decagon, most of us remember, is a 10-sided figure. So, since all of the sides are congruent, I know that 360 is going to be the sum all the way around, and since there's 10 exterior angles, I'm going to divide by 10, and it'll be 36. Alright, the last one to look at, again, this is from last year or the year before, Polygon interior sum theorem. So we're going to start by creating another column, which we forgot. We're going to call it the number of sides. Okay, so how many sides are on this first shape? Well, it's 3, right? And how many triangles are there? Well, we already know this. There's one triangle and a triangle, and that's equal to 180. That's the triangle angle sum theorem. So that part's easy. We're going to take this second shape, which is a quadrilateral, and we know there's 4 sides, and I'm going to draw one diagonal, which creates 2 triangles. Well, since there's 2 triangles, 2 times 180, each triangle is 180, so 2 times 180 is 360. I'm going to do the same thing for each of these. So this next shape has 5 sides, and it will create 3 triangles. 1, 2, 3. Well, because I have 3 triangles, each of them worth 180, that's 540. For a hexagon, there's 6 sides, which makes 4 triangles. 4 times 180 will give you 720. Now, without drawing a picture, I could keep going with my pattern and know that a 7-sided shape would give me 900. But now here's the thing. I want to get down to the end. I want to know how much it would be for anything. So we call that an n-gon. An n-gon is a shape, a polygon that has n sides. So how many sides are on an n-gon? N. And how many triangles are created? N minus 2. Look at the pattern side to side. Each of these is 2 less than the number of sides, right? 2 less than the number of sides. So this is n minus 2. So I'm going to take n minus 2 times my triangle 180, and that'll give me the sum. How does that look? Well, right here, I have to figure out how many sides there are. Since there's 5 sides, I do 5 minus 2 times 180 to get 540. So I know that the insides of this has to all equal 540. And now I can add up all those sides and subtract it from 540 to find that missing angle. Same idea over here. This one also happens to have 1, 2, 3, 4, 5 sides. So 5 sides tells us that 5 minus 2 times 180 is still 540. And now, of course, I need to add up all these sides. It just is algebra instead. And again, I'm not going to show all that work, but you combine your like terms, you end up getting x equals 20. Now, what size is a measure of a regular decagon? Again, we know that a regular means that all the sides are equal. And an octagon has 8. So if I do 8 minus 2 times 180, that'll give me 1080. Now, because they're all the same and I have 8 of them, I can divide that by 8 to get 135 degrees. Or, there's another way I can do this. I could have dealt with the exterior angle. We know that the exterior angles are 360, right? And since there's 8 exterior angles also, I can do 360 divided by 8 to get 45. And now those are the outside angles. So the outside angle is supplementary to the inside angle. And I subtract it to get the 135. Alright guys, good luck tonight on your work. Let me know if you've got any questions.